Good morning, students. As we are discussing chapter Basic Principles of Organic Chemistry, and the very important topic of this chapter is IUPAC Nomenclature. As you know that if we are using common names for different compounds, then it will be very confusing and difficult because common names do not follow a particular rule. Moreover, they are not similar or uniform in worldwide. So there is a proper name given to each and every compound by International Union of Pure and Applied Chemistry. So today we'll discuss IUPAC naming for saturated hydrocarbons. IUPAC name of any organic compound has three parts in it: prefix, word root and suffix. Let us discuss what are these three different parts. Word root actually indicates the number of carbon atoms present in the selected chain. Means the chain of carbon which is selected during naming of an organic compound. If it contains one carbon atom, then the name word root is used. Meth. For 2 it is eth. For 3 prop. For 4 it is but. For 5 carbon it is pent. For 6 word root is hex. For 7 it is hept. For 8 oct. For 9 non. For 10 dec. For 11 undec. For 12 dodec, so on. Suffix is you can say small group of words which is used to indicate further parts of the name. For example, it is of two types. Primary suffix indicates the carbon chain saturation. If all carbon atoms are bonded with single bond, then primary suffix used is ane. But if a double bond or triple bond is present in a carbon chain, then the primary suffix used will be ene for double bond and ine for triple bond. And secondary suffix is added after adding primary suffix in the name of organic compound, and it indicates the presence of a functional group in the molecule. Few examples of secondary suffixes used for functional groups are carboxylic acid, the suffix used is oic acid. Esters, the suffix used is oate. For amides, the suffix used is amide. Cyanide or nitrile, functional group if present in compound, then the suffix used is nitrile. For aldehyde, the suffix used is al. For ketone, the suffix used is on. For alcohol, the suffix used is all. And amines, the suffix used is amine. Next is the prefix. The group of words or group of letters which is used before word root is called prefix, and prefix is again of two types. First is primary prefix. It indicates the presence of carbon ring in an organic compound. It is used only if the compound is cyclic. And the word used for any cyclic compound is cyclo. For example, if the compound has a 5-membered ring of carbon atoms with all single bond present in it, then the name of the compound will be cyclopentane. And second type of prefix used is secondary prefix, which indicates the presence of substituent or side chain in a given organic compound. And a few functional groups which are not considered as functional group, rather they are considered as substituents, are halogens, nitro and ether group. And alkyl groups, all different type of alkyl groups are also considered as substituents. So for all of these, various prefixes are used. Let us see a few examples of secondary prefixes for various substituents. For halogen group like fluoro, chloro, bromo, iodo. For nitro group, the prefix used is nitro. For ether group, the prefix used is alkoxy. For example, if it is OCH3. Then the term prefix used is methoxy. For OC2H5 it is ethoxy. And simple alkyl groups are named in the form of prefixes like methyl, ethyl, propyl, etc. Now we'll discuss rules to name saturated hydrocarbons. As you know that hydrocarbons are the organic compounds having all carbon and hydrogen atoms only. And if all the carbon atoms are linked to each other by just single bonds in between, then those type of hydrocarbons are called saturated hydrocarbons. And general formula for saturated hydrocarbons is CnH2n plus 2. And saturated hydrocarbons may be either cyclic or acyclic. All acyclic hydrocarbons are named as alkanes, and the name comes from by adding suffix "ane" to the word root. Alkanes may be of two types on the basis of their structure. They have, if they have straight chain of carbon atoms, then they are called simple alkanes or straight chain alkanes. And if the chain is branched, then they are called branched chain alkanes or branched alkanes. Now some common names of alkanes are CH4 named as methane in common system as well as in IUPAC system, ethane C2H6, C3H8 propane. Butane may exist in two structural isomeric form. When it is in the form of a straight chain, then it is named as normal butane, and when it is branched, then it is named as isobutane. Similarly, pentane, three structures are possible. Normal pentane, with one branch it is isopentane, and with two branches on same carbon it is called neopentane in common system. Now there are certain IUPAC names for simple alkanes. Having 1 to 12 carbon atoms, straight chain alkanes can be represented by the name alk plus ane. 1 for 1 carbon methane, 2 it is ethane, for 3 carbon propane, then butane, pentane, hexane, heptane, octane, nonane, decane, undecane and dodecane respectively, up to 12 carbon atom present in the form of straight chain. Now we'll discuss if the chains are not straight, means if the compound is a branched alkane, then there are certain rules which are to be followed while giving name to IUPAC according to the IUPAC rules. First rule is you need to select the longest continuous chain of carbon atoms and then use the name of this chain as the parent name of the compound. Second rule is number the largest chain, and the numbering should be done from that end where the substituent gets the lowest position. And third rule is the groups attached to the parent chain are named as alkyl groups, and the location of each alkyl group is also indicated by certain numbers to which they are attached to the main chain. And write the alkyl groups in alphabetical order regardless of their position. While writing the name, you need to arrange those groups in alphabetical order. So firstly, we will discuss how to select the longest chain. As you can see in example, the straight chain has only 5 carbon atoms, whereas the chain, if we extend it towards upward direction, then it will have 6 carbon atom. So we can see that we need to select that chain which contains maximum number of carbon atoms. And suppose if in an organic compound there are more than one chain having largest number of carbon atoms are possible, then we need to select that chain which contains more number of substituents. As you can see here in this example, the compound is same. In first case, the chain selected has only 3 substituents, whereas in second case the chain selected has 4 substituents, and in both of the chains the number of carbon atoms are 7. So In this case, we will select the second one in which more number of substituents are present. Next thing is how to number the parent chain. Now, अब हमने चेन तो सेलेक्ट कर लिया, अब उसके बाद हमने नंबरिंग कैसे करना है उस पेरेंट चेन को. तो नंबरिंग शुड बी डन इन द प्रेफरेंस ऑफ substituent, from which end the substituent gets the lowest position. So lowest lock-in rule is to be applied. And next is the identification of alkyl groups. You need to identify how many carbon atoms are present in that branch or substituent. Accordingly, we can give the name in the form of alkyl by changing the ANE of parent alkane to YL. For example, if we have methyl group, so methyl comes from methane, so the methane name changes into methyl. And similarly, ethyl comes from ethane. There are certain common alkyl groups. You can see for one carbon atom it is methyl group, 2 carbon atoms ethyl, for 3 it may be in 2 forms, straight chain, then it is normal propyl, and if it is branched then it is isopropyl. For butyl group there are 4 different names can be used in common system: butyl, normal butyl, isobutyl, secondary butyl and tertiary butyl. It all depends on the type of carbon which is attached to the chain. Let us see how these groups differ in the further substitution of carbon. For example, you can see isopropyl group is attached to the parent chain with a 2-degree carbon. So this group is also said to be a 2-degree group. Isobutyl group is attached to the main chain with the help of one CH2 group. That means CH2 group is a 1-degree group as it is connected to one carbon atom only. Whereas in secondary butyl, the group attached to the parent chain is a 2-degree, has a 2-degree carbon, means it is further linked to 2 different carbon atoms. So it is a 2-degree group. And this is the basic difference between secondary butyl and isobutyl. Whereas in tertiary butyl, the carbon which is attached to the parent chain directly is a 3-degree carbon, tertiary carbon, that is the carbon which is further bonded to 3 different carbon atoms. And in neopentyl groups, the carbon which is attached to the parent chain is 1-degree carbon, and the carbon adjacent to this group is 3-degree. So this type of position is called neo position. Now next thing is how to give number or name to alkyl groups. So first of all we need to start numbering from that side where the substituent gets lowest position, and after when we'll write the name, we will write the prefix having preference in alphabetical order prior to the next one. For example, here we have 2 prefixes, methyl and ethyl, and alphabetically ethyl is preferred over methyl, so the name would be 4-ethyl 2-methyl हेक्सेन. तो आपको नंबर पे ध्यान नहीं देना कि वो कौन सी पोजीशन पे आ रहा है, उसके अकॉर्डिंग नेम नहीं लिखना. नेम लिखा जाएगा अल्फाबेटिकल ऑर्डर ऑफ नेम्स ऑफ द एल्काइल ग्रुप्स. Now, if 2 or more of the same substituents are present, we can use the prefixes di, tri, tetra, so that we need not to repeat the names. For example, here you can see this compound has 3 methyl groups present on the parent chain. So we need not to write methyl, methyl, methyl 3 times. Rather, we can simply write 2,5,7 trimethyl decane. And one important thing is the position of these groups is must be followed by a hyphen before writing the name. So 2,5,7 trimethyl decane. And one more thing, if different types of substituents are present, don't consider these prefixes di, tri, tetra while deciding alphabetical order. For example, अगर ethyl भी यहाँ present हो chain में, साथ में 3 methyl groups भी हैं, then also ethyl will be, means whenever di, tri, tetra are used for simple substituents, they will not change the alphabetical order. They are just the number of those groups. Now important thing is how to नेम कॉम्प्लेक्स सब्स्टिट्यूएंट्स इन एन ऑर्गेनिक कंपाउंड्स. बट अभी तक हमने जितने भी सब्स्टिट्यूएंट्स देखे वो सब स्ट्रेट चेन में थे, बट these substituents may further be branched. For example, here you can see this substituent attached to this chain at 4th position is a branch group. So this kind of complex substituents are to be named separately. In common system, so this can be used as isopropyl group. IUPAC and also recommended this common name use of for these complex substituents. आप वो भी use कर सकते हो, but as per the rules of IUPAC, they are to be numbered in such a way that जहाँ से complex substituent पेरेंट चेन के साथ अटैच है उस कार्बन को आपने नंबर 1 देना है. उसके बाद एक लॉन्गेस्ट चेन उस ब्रांच में सेलेक्ट करनी है, एंड लेटर ऑन जितने सब्स्टिट्यूएंट उस मेन चेन में नहीं आ रहे उनको आपने अलग से एज अ प्रीफिक्स यूज करना है. फॉर एग्जांपल, इफ वी कंसीडर दिस complex substituent having 3 carbon atom, 2 carbon atoms are in straight chain, 1 and 2 as numbered in the group, and 1 methyl group is left which is not included in the chain. So this would be named as 1-methyl ethyl, and this is the name of complex substituent alone, 1-methyl ethyl, which is to be mentioned in bracket, and it is actually written after the position by which it is attached to the main chain. तो ये 4th position पे लगा हुआ है main chain पे, तो start numbering will or name of the compound will start with the position first, 4 hyphen bracket 1-methyl ethyl bracket closed, then the parent name is heptane. So in this way complex substituents can be named. Next is when 2 chains of equal size are present. For example, if a chain contains, if an organic compound has possibility of 2 chains of equal size, then again this rule we have already discussed, we need to select that chain which has larger number of substituents. So in this compound, the chain selected is starting from 1, 2, 3, 4, 5 towards the left side. It is of 10 carbon atom containing 3 substituents attached at 2nd, 3rd and 5th carbon atom. And here we have 2 methyl groups and 1 complex group present in this in this compound. So we need to select this chain having 3 number of substituents. And this compound can be named by giving the numbers to complex substituent 1, 2, 3, 4. As I told you that 1 is to be given to the carbon which is directly attached at the 5th position. Later on we can extend the chain in any direction, and the name of this complex substituent would be 2-ethyl butyl, and at 5th position, and 2 methyl groups are present there, so we need to write name in alphabetical order. So ethyl butyl comes prior to methyl, hence the name would be 5,2-ethyl butyl 2,3-dimethyl decane. Next is while considering complex substituent, जब हमें alphabetical order यूज करना है, कॉम्प्लेक्स सब्स्टिट्यूएंट अगर प्रेजेंट है कंपाउंड में, एंड यू नो दैट कॉम्प्लेक्स सब्स्टिट्यूएंट्स will have some prefixes like di, tri also in the name itself. So that di, tri, tetra which are the name, which are the part of the name of that complex substituent are to be considered while deciding the alphabetical order. For example, here in this compound you can see that the complex substituent attached at 5th carbon has 2 methyl groups. The name is 1,1-dimethyl propyl, and 1 ethyl group is present at 4th carbon atom. So the name will be, guess, 5,1,1-dimethyl propyl. Here this D will be considered for deciding the alphabetical order, as dimethyl is a part of the name of this complex substituent. and ethyl will not be given preference. Next is, if two similar types of groups are present but they have just difference in the number of locant only, means the groups are of same carbon atom, same name is there, just the number of complex substituents differ in just the number of the position of the group. In that case, alphabetical order will be decided by looking at the numbers. Having the lowest locant will be preferred. For example, in this case, the name would be 5,1-methyl propyl 6,2-methyl propyl decane. 1-methyl propyl has lower number or lower locant as compared to the 2-methyl propyl. Now this is again important. If two similar type of complex substituents are present on the in an organic compound. For example, here you can see as we select the chain starting from left side, carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 carbon atoms are present in this longest chain, and two groups having similar structure of 4 carbon atoms. Both of these are branched groups, and as you can see that these two complex substituents have exactly similar structure, and the name of these complex groups are 1,1-dimethyl ethyl. So if two groups are of same types, then no need to write the names again. We need to use certain prefixes, like if two groups are present, then write bis. For 3 we can use tris, and for 4 we can use tetrakis. So the name would be 4, 6 bis. 4 and 6 are telling the positions of these two groups. Bis means two complex groups are there, and then start bracket 1,1-dimethyl ethyl bracket closed and no name. So this is the name of compound having two similar complex substituents. Next compound we have 1 complex group and 3 methyl groups. So here we need not to consider these trimethyl, T of trimethyl groups for deciding the alphabetical order. Only the complex substituent whose name starts with di-tri are to be considered while considering alphabetical order. For example, the name of the compound is 2,2,7-trimethyl 4,1-methyl propyl nonane. Here methyl propyl will not be given preference over trimethyl, because trimethyl का T हमने consider नहीं करना है. Only methyl is to be considered while deciding alphabetical order. Di, tri, if they are the part of the name of complex substituent, then only they are to be considered in alphabetical order. For simple substituent like methyl, ethyl, propyl, if they are not branched, then no need to consider their number di, tri, tetra in alphabetical order. I hope the rules are clear to you all. Thank you and have a nice day.